let x1 of t and x2 of t be the two linearly independent solution of the differential equation d square x divided by dt square plus 2 dx by dt plus f of t x equal to 0, and let w of t equal to x1 of t dx2 by dt minus x2 of t dx1 by dt. Then they are given the initial condition w of 0 equal to 1. Then what is the w of 1 that we need to find? So let's write a differential equation first. The given differential equation is d square x divided by dt square plus 2 dx by dt plus f of t x equal to 0. That's a given differential equation. So x1, x2 be the solution. So it will, the x1 of t will satisfy the equation, x2 of t also will satisfy the equation. Write the x1 of t. So d square x1 by dt square plus 2 dx1 dt plus f of t x1 goes to 0. Next, x2 of t is the solution. So d square x2 dt square plus 2 dx2 divided dt f of t x2 goes to 0. Next, we need w of t. W of t equal to x1 of t dx2 by dt. So from these two equations, you need to find dx1 of dt, dx2 of dt. Then we have to substitute back in the w of t. So first find the dx1 of dt from the first equation. That will give us dx1 of dt should be equal to 1 by 2, make the whole bracket, minus d square x1 divided by dt square minus f of t into x1 of t, or else you can call it f1. You can take all the variables all like a dependent variable, it's dependent on the t. From the second equation, this is the first equation. From the second equation, you need to find the dx2 of dt. So dx2 divided by dt equal to same 1 by 2 minus d square x2 divided by dt square minus f of t into x2. Now substitute the dx1 by dt, dx2 by dt in the w of t. So the given w of t, separate the partition, w of t should be equal to x1 of t, it's function of t, x, all the variables are function of t, dx2 by dt minus x2 of t, then dx1 of dt. Now substitute here. So x1 of t, substitute dx2 divided by dt, that's value is here. So that should be equal to 1 by 2 minus d square x2 divided by dt square minus f of t into x2. Here these x2 variables are is function of t minus x2 function of t. Write the dx1 divided by dt from the this equation, that should be equal to 1 by 2 minus d square x1 divided by dt square minus f of t x1. Now let's take the common thing out. 1 by 2 you can take common from this 2 term. Then you have to multiply inside everything. Make the big bracket. So minus x1, I do not write the function of t for right now solving purpose, d square x2 by dt square, it's a function of t only. Then if I multiply with that one, minus f of t x1 x2. Then here outside is minus, minus into minus plus, 1 by 2 already here taken common out. So this should be equal to x2 d square x1 by dt square minus into minus plus f of t x2 x1 x2 x1. So x1 x2 here x2 x1. they will come out with each other. So this value is equal to this value. So big here minus here plus, you can cancel these two. Now the simplified equation, still from these two terms you can take like a d by dt common out. If you are taking d by dt common out, inside it will be, first write this one, x2 dx1 by dt minus x1 dx2 by dt. Now let's see. If you are taking differentiation with respect to this term, you have to use the product rule, dx2 by dt, dx1 by dt plus x2 d square x1 by dt square, you will get this term. Then same way if you multiply here, minus dx1 by dt, dx2 by dt, then minus x1 d square x2 by dt square, you will get the first term, but here one extra term, here one extra term, it will get cancel each other because plus and minus. So finally you will arrive at the same equation. That's why I have taken common out. This should be equal to w of t. Now let's see, x2 dx1 by dt minus x1 dx2 by dt, that should be equal to minus of wt. So this one I can write w of t equal to 1 by 2 d by dt minus w of t. Now you can rearrange the variables are one side, the w of t is one side, then dt is other side. So this minus you can take common out, you can take it out. dw of dt divided by w is equal to 2 times dt. Now you can bring the minus also here. Take the integration on both sides. We know the limits, it's indefinite integral. So if it is indefinite integral, you have to add some constants. So the integration value is 2t plus some constant c should be equal to dw by w, it's log w, the integrate value. So log w of t. Now we need to find the constants. So we know the given first condition w of 0 equal to 1. So let's take the value. At t equal to 0, the w value is 1. This is the first condition. So at t equal to 0, take at t equal to 0, w of 0 equal to 1. If you are using this condition, minus 2 times 0 plus c, we don't know what it is, log of, let's take general natural logarithm for the integration purpose. So ln of w of 0, wherever t is the, we put substitute w, so it's a 0 plus c equal to, the w of 0 value is 1, so ln of 1 is 0, so c goes to 0. So the constant is now, it's a 0. Now let's erase this given equation. The solution w of t equal to minus 2t equal to ln of w of t. We need to find w of t only, the solution. So erase these two terms. So take the natural log exponential on both side, e power minus 2t equal to, e power ln will get cancelled, the w of t. So at t equal to 2, at t equal to 1, we need to find what is the answer, w of 1. So at t equal to 1, then e power minus 2 equal to w of 1. Wherever t is, we get to substitute 1. So w of 1 equal to 1 divided by e square. This is the answer for the given question w of 1.